Welcome to a video on angle bisectors. Sounds like fun, right? We're on page 13 in the packet, and let's just jump right into it. I guess, by the way, if you have any questions on the homework from last night, we can go over them when I see you next. So just hold on to them and remind me next time I see you. So let's start off with congruent angles. So we've already learned about congruent segments, okay, which is when two segments are congruent when their lengths are equal. So a similar idea happens with congruent angles. Two angles will be congruent if they have the same measure, all right? So if I have an angle chilling right here and another one chilling right there, let's just call this angle A and this one angle B. If they have the same measure, which we indicate graphically by putting a little swipe there, so kind of a curved line, a little arc, I call it a swipey-do personally. If we have that little swipey-do there, that means that they have an equal measure. If they have an equal measure, then we say that they're congruent. And just things to highlight is that measures are equal to each other, whereas angles can be congruent to each other. All right, so we would never write like the measure of angle A is congruent to the measure of angle B. That doesn't work. The measures are equal to each other. We would never say angle A equals angle B. We would say angle A is congruent to angle B. So when we look at this first example here, right, we have identify all pairs of congruent angles. And when we look at the picture, we have angle Q has one swipe, angle U has one swipe. S and V both have two, and then R and W both have three. My phone went off because I forgot to put it on Do Not Disturb. I am the worst. Fixed it. All right, so we can use our shorthand notation for all of these because there's no ambiguity about what like angle Q, R, or S would be. So we can say angle Q is going to be congruent to angle U. And that's because they both have one swipe mark there. If they have one swipe mark, that means that they have an equal measure. If they're equal measure, they are congruent. We can also do angle S is congruent to the one that also has two swipes. So that's going to be angle V. And then we have last that angle R will be congruent to the other one that has three swipes, which is angle W. So there we go. There's all pairs of congruent angles. Now, in an ideal world, you would pause the video and you would try to do 2A and B yourself. Now, I'm pretty realistic in that you're probably not going to do that, but it would be great if you did. To try it on your own, I'm going to go over it now, though. Feel free to pause. That was me pausing to give you time to pause. Did it work? No? Okay. Well, we tried. Let's get ourselves a nice, fun purple color. First, identify all pairs of congruent angles. All of the angles over here, there's no like wishy-washy about which one's which, so we're going to be able to just say angle P, Q, R, S, or T. We don't have to use the three-letter notation. You can if you want to. But when I'm looking at this, I can say angle P is going to be congruent to angle R because they both have two swipes, and angle T is going to be congruent to angle S because it has one swipe. And we don't know enough about angle Q to say anything about it right now. In the diagram, the measure of angle PQR is 130 degrees. Okay, so that's 130 degrees. Measure of angle QRS is 84, so that's over here, 84. And then measure of TSR is going to be 121. So that's what they gave me. And because I know that angle S and T are congruent, they have equal measures, so this is also going to be 121. So the measure of angle T is going to be 121 degrees. And if we want to get fancy, we could use the three-letter notation, PTS or STP. Either way, it works. And then we have that P is going to be 84 degrees because it is congruent to R, which means they have the same length. So again, we can say the measure of angle P is equal to 84. And if we want to get a little more fancy, we would say the measure of angle QPT, or we could do TPQ. Either way, it's going to work out. And there we go. That was fun. All right, we finally get to angle bisectors now. So an angle bisector is super similar to what a segment bisector was. A segment bisector was anything that split the segment into two equal lengths. So an angle bisector is going to be anything that takes an angle and splits it into two equal measures. Okay, so I'm going to draw this thing in right here. This would be the angle bisector. Bisector, there we go. And it's going to split this angle into two equal parts. All right, so the two swipe marks, remember that means that they're going to be the same. So this angle right here that I just highlighted in yellow is going to be congruent to this angle right here, which means that they have equal measures. So if it says something like there's an angle bisector here, you know automatically that it's creating two angles that are equal in measure. All right. We were going to do this super fun activity where I was going to actually have you draw all this, like actually do this exploration of folding a piece of paper to see how we can create one if we have a physical plane. If you're super interested in doing that, we can do that next class. We'll have time. If you're not interested in doing it, then we'll skip it. I'm going to jump and show you the GeoGebra. You're more than welcome to try it yourself as well if you want to pause. So here is the GeoGebra example. We have this lovely triangle right here. I'm just going to kind of move it to be a little bit more in the middle of the screen. And if I show the three angle bisectors, okay, so that's the three lines that are in here, they actually all intersect at the same point. And that's pretty neat, actually. And there's a lot of really cool properties that happens with this point in particular. So one is that obviously it's going to split all of these angles and they're going to be congruent. So the ones at B split in half, they're congruent. The ones at C split in half, they're congruent. The ones at A split in half, they're congruent. There's actually other ones. I'm really hoping that you can see my mouse here, but this angle right here is actually congruent to this angle right here. This one is congruent to this one, and this one is congruent to this one. And then we also have that this angle right over here, where my mouse is chilling, is actually congruent to this angle over here, and it kind of goes the same way. This one with this one, and then this one with this one. So this creates a whole bunch of congruent angles, so angles that have equal measure. There's also something kind of neat. Let's see if I can get it to not show as much stuff here. That same point right there actually is equidistant, which means that it's the same distance from all three sides of this triangle, which means that we can actually draw a circle that just fits perfectly inside the triangle ever so slightly, where it just touches the edge on all three sides of it. And this is referred to as an incenter. And there's a whole bunch of these other ones. There's four big ones. I never remember the name of all of them, but there's incenter, there's an orthocenter, there's like a circumcenter, and something else. But we're not going to do those right now, so we're not going to focus on them. But I just wanted to show you that angle bisectors have a real use, and that they do some really cool stuff with other things than just angles, like when we do a triangle. All right, I know that was the most fun you've ever had in your life, so let's just keep going with it. Here I have, if it lets me change colors, there we go. A typo, number one, is this is supposed to say YW, not XW, is an angle bisector, so that's that lovely line right there. There's kind of a thick highlight. Let's make that a little bit less aggressive. All right, so that is the bisector. And because of that, we know that it's going to split this into two equal parts. So that part right there and that part right there are going to be congruent to each other. If we want to be like super official about how we're writing stuff, we would say that the measure of angle XYW is going to be equal to the measure of angle WYZ. And since we know right here that XYW is 18 degrees, then we automatically know that the measure of letters WYZ is also 18. So basically this is 18 degrees and this is 18 degrees. They asked us specifically to find the full length. So I think you probably know that we can just add them together by now, but if I'm being super formal, what I would have to write is that the measure of XYZ, what I want to find, is actually made up of two angles, XYW plus the measure of angle W, Y, Z. And since both of those are 18, we can do 18 plus 18, and we're going to get 36 degrees. So the measure of angle XYZ is going to be 36 degrees. On a test or quiz, you wouldn't need to show me all of that work. You would probably show me at minimum, like what's in red there that you know. Here, I'm going to highlight what you would probably show me. You would probably want to show me this part right here, and you would probably want to show me that you were doing 18 plus 18 in order to get the 36. So that would probably be the work that you would show me. Ooh, another your turn. So exciting. Let's read this one through, and then you should pause the video to try it yourself. So it says, MNP is a straight angle. What do you know about straight angles? You're totally right. They add up to 180 degrees. It also says that NQ is going to bisect angle MNP. So if we bisect something that is 180, that means that we're going to be cutting it in half, and that means we're going to be creating two 90-degree angles out of this. So it wants us to draw MNP and the NQ, which is bisecting it, and then use arcs to mark up our diagram, basically, to show that things are congruent. So you should pause the video and try it. That was the pause. If I'm going to draw a straight angle, I basically draw a straight line, and I'm just going to label this M, N, and P. Then I'm going to label NQ. So NQ is going to be a ray itself. And what I know from this is that it is bisecting it, and it's going to create two 90-degree angles. So this is going to do everything that I need it to do. It's showing on the diagram that they're congruent to each other because all 90-degree angles are congruent to each other because they all have a measure of 90. And I've also marked that that is what the actual measurement is. All right, there you go. That was the official lesson. What you should do for the rest of class now is work on this practice. It's not the most craziest, hardest practice. There's also optional ones. I'll give you one tiny hint. For 3, you should draw like a really big angle the first time that you do this, because you're going to end up like cutting it in half and cutting it in half and cutting it in half like multiple times. So the bigger you draw your first angle, the easier it's going to be for you to label all the different things to try to figure out what's going on. And then you should obviously use the letters that it's saying. So like this would be RST, and then we cut it in half with SQ. So then Q would be chilling right here. And then the next one is saying like SP is cutting RSQ in half. So then this would be the one that is cutting that. I guess I'm kind of just doing this one with you now because we've done this much. SV is going to be chilling right here. And then it tells us that VSP is going to be 17. So what we need to do is backtrack and try to figure out which angles are congruent based off which things were bisected. And then we can kind of build up what the big TSQ would actually equal. So that's my hint for that one. Use class to practice the rest of this stuff. You have no official homework this weekend, just to do whatever practice you feel like you need to do. Alrighty, I will see you next week. Bye.